Hey everyone, hope you guys had a great weekend. So what I want to do is just create a video of me going through all these different odd numbered problems on this review for the assignment that you guys have to complete today. So like I said in the post, it is a YouTube link, so feel free to skip around and view whichever problems you guys would like to that maybe are a little bit more challenging than the other ones. All right, so all we had to do with the odds. So let me zoom in to give myself a little bit more room. All right, so let's start with number one first. So remember, guys, when you're solving, there's kind of three main strategies that you want to kind of take a look out for. So the first one is always trying to get the trig function by itself. So when you're looking at a problem like number one, it's not really going to help too much because you see that you have two different cosines going on. You have a cosine of the second and then another cosine of the first. The second thing that you always want to look for is to see if you can factor. Now, especially when you have see two different cosines going on in this problem, this is a pretty big hint that you're going to try to factor this one. So when you start off with a cosine squared, then a cosine of the first, then just a number by itself, when you factor this, this is going to factor into your two sets of parentheses. All right, since this 2 is out in front of that cosine squared, one of your cosines is going to have a 2 out in front of it. The other cosine is just going to be by itself. So we're thinking about our factors of 2 with our factors of 1 that we could then add together to give us 3. So we know 2 times 1 gives us 2, and 1 times 1 gives us 1. And in this case, they're both going to have to be minuses. All right, so once you guys have this factored, now you're going to set each one of these groups equal to 0 and then solve for cosine. So on that left group, when we solve for cosine, we're going to end up getting cosine x is equal to a positive 1/2. For the right group, you guys are going to end up getting cosine x is equal to 1. All right, so if you look at these two different equations that we now set up, if we look at this left side, now here's when you guys want to start thinking about, all right, am I working with a special angle or am I working with a non-special angle? So in this case, since cosine x is equal to 1/2, we know we're definitely working with a special angle, and this is going to be a pi over 3. And then to figure out what quadrants I'm in, remember, since we're working with cosine, and cosine really is with x, we're saying that x is not only 1/2, but it's a positive 1/2. So that means x is positive in quadrant number 1 and quadrant number 4. So two of your answers for x from this left side, in quadrant 1, we get pi over 3. And then in quadrant 4, we go 1 less than 2 pi, which would end up giving us 5 pi over 3. All right, if you guys look on this right-hand side and you have cosine x is equal to 1, remember, similar to what we talked about on the left side, but we're really saying that x is now a positive 1. So x is going to be a positive 1 at this value right there, right on the positive x-axis. So because the directions say 0 and 2 pi, and the 0 is included and the 2 pi is not, technically that answer would be 0. But if you guys ended up writing 2 pi, I understand that you understand the concept, so I would take that as well. But your three answers for this problem would be pi over 3, 5 pi over 3, and 0. All right, looking at number 3. So you have sine to the third of x minus sine of x is equal to 0. So really similar to what we did on problem number 1 is you're going to have to go through and solve this one by factoring because we see two different signs going on in the same equation. So when I factor, in this case, I can only take out a greatest common factor, which is just sine of x. And that'll leave you with sine squared x minus 1, and that's equal to 0. All right, so now similar to that last problem, you have two groups. Now each of those groups you guys want to set equal to 0 and now solve. So setting sine of x is equal to 0 just gives us 0, right? Setting my right side equal to 0, you're going to have to do a little bit more work. And I was actually going to write this out to show you. So when you start setting this equal to 0 and solving, you guys are going to add 1 to both sides to get sine squared x is equal to 1. Now, at this step, though, this is when you want to get sine by itself. by taking the square root of both sides. So when you do that, you now have sine of x is equal to, and then just don't forget that plus minus sign there anytime you guys take a square root of both sides. So you get sine of x is equal to a plus minus 1. All right, so if we go back and we look at this left side, when we have sine of x being equal to 0, remember now, since we're working with sine, what we're really saying is that our y value is 0. And where our y value is 0, if we think about like our plane, we have these 2 points. So 2 of my answers are going to be my positive x-axis, which is 0, and my negative x-axis, which is just the angle measure of pi. If we look to the right side now, really similar. So when we know that we have sine of x is equal to a plus minus 1, what we're really saying, since we're working with sine, is that y is equal to a positive or negative 1. So where we want to think about y being a positive or negative 1 is if we look at our coordinate plane, that means that y is positive 1 up top and y is a negative 1 on the bottom. So that would give us the two answers of pi over 2 and 3 pi over 2. Right. And those would be your 4 answers for problem number 3. All right, so now let's look at number 5. All right, so for number 5, you guys have 20 cosine squared x minus 17 cosine x plus 3 is equal to 0. All right, so the setup of this one is really pretty much identical, just the numbers are kind of switched around to problem number 1, where when you take this and you're solving it, you're going to have to try to be able to factor. All right, so the only way that we can factor this is if we set up our 2 sets of parentheses and then go from there to get those 2 different groups. Now, since you guys notice, again, you have this 20 in front of your first cosine squared, you're thinking about the factors of 20 with your factors of 3. That'll give you that 17. So we're going to factor this one into 4 times cosine. I don't know why this is not working. Hold on. All right, let's try this again. So you're going to have 4 times cosine of x. And then this is going to start with 5 times cosine of x. All right. It's going to get the 3. This will get the 1. And then in this case, both of them are going to be negatives. All right. So this is going to factor into 4 cosine x minus 1 and 5 cosine x minus 3. All right. So now that you have your 2 groups, just like we talked about before, you're going to take these 2 groups and you're going to set each of them equal to 0 and try to get cosine by itself. All right. So when we focus on this left side, we're going to add 1 and divide by 4. So that's going to give us cosine x is equal to positive 1/4. On my right-hand side, when we solve for cosine, we'll get cosine x is equal to positive 3/5. All right. All right. So once you guys are at the step, now I know before in problems number 1 and 3, we had special angles, but now once you're here and you're looking, and maybe I'll draw this line down to help us kind of separate them. But now when you're looking at cosine x is equal to 1/4 and cosine x is equal to 3/5, that should kind of set an alarm off to you guys that you're working with non-special angles, because the 1/4 and the 3/5 are obviously not any special x or y value that we know from our special angles. So these are going to be non-specials. So remember, with non-specials, the first thing you have to do is you have to find that reference angle. So I'm going to kind of start with my left side first. So when I find my reference angle, I'm going to have to use my calculator and do the inverse of cosine of 1/4. That'll give me my reference angle that I really need to help me get my other angles. So when I do that, in this case, I end up getting a 1.318. So that's my reference angle for that left side. Next thing I got to do is after I find that reference angle, then identify what quadrants I'm in. So when you guys are identifying your quadrants, it's the same thing like you did for 1 and 3. Since you're working with cosine, and in this case it's a positive 1/4, that means x is positive. So x is positive in quadrant number 1 and quadrant number 4, which means, and I'll write this in a different color, when we go through and we find our final answers, quadrant number 1 is just going to be whatever our reference angle is. So that means we're going to have our 1.318. All right. But when we get to quadrant number 4, remember your closest x-axis is 2 pi. So you have to take 2 pi and subtract your reference angle from it. So 2 pi minus 1.318 is going to give you 4.965. All right. Okay, so those are the two answers from your left side. All right, so if we go back and look at our right side now. So same thing. First thing you guys are going to have to do is use your calculator. Find that reference angle by doing the inverse of cosine of 3/5. And this gives us a reference angle, in this case, of 0.927. When we go to identify what quadrants we're in, same thing, because that 3/5 is positive, that means x is positive, and x is positive in quadrant number 1 and quadrant number 4. So then when we go to write our final answers, quadrant number 1 is going to be my reference angle. So that's going to be our 0.927. And quadrant number 4, just like we talked about, take 2 pi minus the reference angle, and that's going to give us 5.356. And these are our 4 solutions to this problem. All right, so let's move on to number 7. All right, so when you guys are looking at number 7, you have 2 cosine squared x minus 2 cosine x is equal to 0. All right, so same thing. When we go through and we solve this, we see 2 different cosines. So that means that we're going to have to try to factor to solve this. So the only way that we can factor in this case is by taking out our greatest common factor. So when we take out our greatest common factor, we're allowed to take out a 2 cosine x. And when we do that, that's going to leave us with 2. I'm sorry, not 2. Let me take that back. 2 is not out in front. When we take out a 2 cosine x, that just leaves us with cosine x minus 1 in our parentheses. So we have 2 cosine x times cosine x minus 1 is equal to 0. Just like we talked about in those last problems. Here's where you guys now finally have your 2 groups. Set those 2 groups equal to 0 and try to solve. So when we set 2 cosine x equal to 0 and we solve, when we divide by 2 to get cosine x by itself, we know 0 divided by anything is just 0. So this first group is just going to give me cosine x is equal to 0. My second group, when I add 1 to both sides, is going to give me cosine x is equal to a positive 1. So on my left-hand side, remember, now that you have cosine x is equal to 0, what that really is telling us is that x is 0. So we want to think about where x is going to be a value of 0. There's 2 spots in this case, and it's going to be your positive and negative y-axis. So just from that left side, 2 of our answers are going to be pi over 2 and 3 pi over 2. If I look at my right side, I have cosine x is equal to positive 1. Well, if we think about where x is a positive 1, there's only one value, and that's your positive x-axis, which is our angle measure of 0. So in this case, our 3 answers are going to be pi over 2, 3 pi over 2, and 0. All right, let's look at 9. So we haven't seen one like 9 yet. I think the solving strategy is going to be the same, and you guys are going to see that in a second. But what I mean by we haven't seen it yet is we haven't seen, in this case, like a cosecant, right? Like so far, all we've been dealing with are sines and cosines. So when you guys do see a cosecant or you do see a secant or tangent, treat it the same way that you want to try to get that by itself. But at the very end, we're going to kind of take one more additional step to get it into like a sine or cosine or tangent or something that we know how to work with. So the first thing on number 9 is when we see two of these cosecants. Hold on. When we see, again, two of these cosecants in the same equation, good chance that you're going to have to factor. And since you have a cosecant squared, cosecant, and the number by itself, when we factor this one, we're going to factor this into our two sets of parentheses. We're going to start each set with a cosecant x. And then our factors of 2 to give us that -1 in the middle. We know the only factors are 2 and 1. 2's got to be negative. The 1 has to be positive. All right, so now once we're here, we're going to set each of these groups again equal to 0 and solve. So my left group is going to give me cosecant x is equal to a positive 2. And the right group is going to give me cosecant x is equal to a -1. All right, now once you guys are here, this is the step that you want to take this, and now with cosecant, we want to rewrite it in terms of sine. So we know that cosecant and sine are reciprocals of one another. So if I focus on this left side first, and I want to take this cosecant, and I want to write this instead as sine, that means that I'm just flipping it, right? But if I'm flipping the left side, I also have to flip this right side. And this 2 is really a 2 over 1. So when I flip 2 over 1, it's going to end up giving me 1/2. So you always want to rewrite it in something like sine or cosine or tangent, or something that you know how to get those special angles from. All right. So I'm just going to focus on the left side and finish this out. Then we'll move over to the right side. So now that you guys have sine of x is equal to 1/2, this is when you can start thinking about your special angle, the quadrants that you're in, to get your final answer. So in this case, we're being told that y is equal to a 1/2, which means that we know we're working with the special angle of pi over 6. And if we need to think about what quadrants we're in, since the 1/2 is positive, we're thinking to ourselves, where's y positive? And that's in quadrant number 1 and quadrant number 2. So I'll write my final answers over here. So when we go through and do this, quadrant 1 is going to give us a final answer, or an angle of pi over 6. Quadrant 2 is going to give us an angle measure of 5 pi over 6. All right, so let's look at the right side now. So same thing on the right side. That cosecant x, I'm going to rewrite that instead as sine. But if I'm flipping the left side, that means I have to flip the right side. Now, when you guys flip the right side, when we flip -1, flipping -1 just gives us -1. So that means when we go through and we want to think about where, in this case, y is -1, y is -1 and only one value, and it's at that negative y axis. So this would give us another angle measure of 3 pi over 2. So you get pi over 6, 5 pi over 6, and 3 pi over 2. So again, guys, anytime you're working with cosecant or secant or even cotangent, always flip them to turn them into sine, cosine, or tangent. And then just make sure you flip the number as well. All right, so let's move on to 11. So when you guys get to 11, here's actually the first problem that we see that we're not going to have to factor. So in this case, there's only a tangent squared going on. You just see that one tangent. So that means you just want to try to get that tangent by itself, just like solving a normal equation, just by getting everything else to the other side. So in order to do this, the first thing that we want to do is let's subtract 4 to both sides. So we have 3 times tangent squared x is equal to 1. Then we're going to divide by 3. And we're going to get tangent squared x is equal to 1/3. Now, at this point, you don't have tangent by itself because it's tangent squared. So that means that you're going to have to take the square root of both sides. So now that's going to leave you with just a tangent of x on the left side. On the right side, remember, anytime you guys are taking a square root, you need that plus minus sign. The square root of 1 is just 1, so I can leave that there. But then when I take the square root of 3 on the bottom, that's going to stay the square root of 3. So remember, when you guys get to a step like this, you can't leave that root on the bottom. So what you're going to have to do is you might have to show a little bit of work, but to get rid of that square root of 3 on the bottom, you have to multiply the bottom and the top by that root 3, because that'll get rid of it. So then when we do that, let's see if I have enough room. So that'll end up giving us tangent x is equal to, still have our plus minus sign. 1 times root 3 is just root 3. Root 3 times root 3 ends up giving us 3, right? So we end up with tangent x is equal to a plus minus root 3 over 3. All right, so once we're here, remember, when we're working with tangent's really y over x. So what we're saying here is that y over x is equal to root 3 over 3. So just think about your special angles and which one, when we put y over x, will give us that root 3 over 3. In this case, it's going to be 1/2 over root 3 over 2, which means that we are working with a special angle of pi over 6. All right, since we're working with pi over 6, since y over x, or tangent, is equal to a plus minus, that means in this case that you are going to be in all 4 quadrants. Anytime you see that plus minus, you're going to be in all 4 quadrants. So when we write out our final answers for x, quadrant 1 is just going to be pi over 6. Quadrant 2 is going to be 5 pi over 6. Quadrant 3 is going to give us 7 pi over 6. And then the last one, quadrant 4, is going to give us 11 pi over 6. All right, so those are 4 answers. All right, so last one we're going to do is number 13. Okay. All right, so when you guys look at 13, I'm just going to erase a little bit from the last problem just to kind of give us some room. All right, so when you guys look at 13, 13 is really similar to number 11, where you're not going to have to factor this problem. Yeah, you know what? You actually could if you wanted to. But since you see that one cosine just by itself, we're going to take the last step just like we did on number 11. We're just going to get cosine by itself by just solving the equation. So the first thing we're going to do is we're going to add 1 to both sides. So we're going to have 4 times cosine x is equal to 1. Then we're going to divide by 4 and get cosine squared x is now equal to 1/4. Now, this step, we want to try to take the square root of both sides to get just cosine by itself. So just like we talked about in that last problem, make sure you guys have that plus minus. So this is going to give us cosine x is equal to plus minus. Now the square root of 1 is just 1. The square root of 4 is 2, which makes this problem easy because you don't have to multiply the top and the bottom by anything. All right, so once you guys have this, that means that x is really a 1/2, which tells us that we're working with a special angle of pi over 3. Since I'm seeing that this 1/2 has a plus minus sign in front of it, that tells us that x is positive and negative, which means I'm in quadrant 1, 2, 3, and 4. So my final answer, my final angle measures for this problem, x is going to equal pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so if you guys have any questions at all on any of these review problems that we did, please just let me know. I'll get back to you as soon as I can. And hope you guys have a good rest of your day. All right, thanks.